notice if you zoom up on this, it's setting to do stair steps. This is kind of the purpose of the dynamic roughing strategies, which is adaptive, 3D adaptive. So we want to come sort of close to the shape if we can. All right, so it's able to get down low. Oh, it rolled right into the next tool. I'm sorry. Hold on a second. So if we look at this after, this is really just looking at that operation right there, how far it got, and it's showing you the tool path also. But we can kind of look up here. It didn't get too far on the curve down. It actually was able to do the outside really good, but not so good on the inside. So I could keep this one and add a tool in between, or maybe I could go to 3/8 tool, because I think I can rough just as well with the 3/8 tool, get a little deeper inside. All right, let's go back to some settings here. So we got machine shallow areas, minimum shallow step down, optimal load, flat area detection, fine step down. This kind of regulates the stair step effect. Maximum roughing step down. This is the how far down do you plan on going, and you can go beyond the model because you really identified the model, so it's not going to go. So if you do this on a shallow number, you might notice that the external cuts might do it in layers. So if I change this to 0.4 and hit, let me just shrink this up here, hit OK. Give it some simulation time. All right, as it comes back, because I changed that step, notice it's doing like multiple depth cuts, like this. This layer right here could have we could have done this all in one step. But because we set a limit of how far down to go, it's doing it in layers. So the tricodial motion allows you to do full depth cuts, but slight sideways adjustments, versus traditional pocketing or traditional roughing was done in layers, stepping down. We're stepping over, but we can go full depth cuts. That's the advantage of this style. So I'm going to go back and change this number here to be at least as big as the height of the part. So I'm going to make it 0.8. Fine step down, and some of these numbers you might use as standards to play with. I'm going to leave 20 thousandths of material radially and axially. And I'm going to turn on smoothing. Let me squeak this up a little bit here. I like to call this, it's like a code shrinker. If you hover over this, it'll give you a little description. But what it basically does is, it's going to create a lot of code, and it's going to try to do all G1 moves, even in curves. Most machines can do arc commands. Like to do this arc can be done in one command, versus little tiny lines. So by turning on smoothing, and I put a rough tolerance on there, better than what the part should be, so then I can start to turn any potential lines into arcs, so it kind of shrinks the code up. It also helps processing time. So there's a lot of settings in here, but they're kind of dynamic on each other. And the last tab is linking. We got full retraction, and this other settings I like in here is the knot engagement feed rate. These are, as it cuts, if you're not going back and forth, we're cutting in one direction, the climb milling direction. So it's repositioning. So it's doing it with a G1. It's not doing it rapidly, but we can kind of simulate rapid positioning by just turning this on. So I have my default set up at 400 inches a minute, which is really the feed rate of our slowest machine can go. And you can go faster than this. And I have a lift height here. This is as it retracts, instead of dragging along the material, it's going to just ramp up a little bit and reposition. So it cuts, lifts up as it retracts, at the fast speed rate, and goes back down and cuts again. This will be a good time saver. And the stay down level is, it kind of does some math on, do I need to stay down or do I need to go up and back again? So you're kind of based on percentage there. And it's those yellow lines that are going up and down. So these are biggies right here. Ramp would be how you cut inside of a part. I like helical ramp milling is probably the #1 choice. But if you hover over this, it'll give you all your choices, like plunge outside stock if you have that opportunity, pre-drill a hole or just plunge straight in, or zigzag, which is it's a style of ramping, but it just stays in one line. So, all right, this is our standard like Helix 2-degree angle. And you can change the size of if you're not getting any ramping, it might be because your diameter is too big. So you might have to play with the diameter a little bit if you have this engaged. All right, I'm going to switch to a smaller end mill as I described before. And I'm going to pick our milling flat end mill. And we're going to go from 1/2 inch to 3/8. I'm going to use the adaptive setting. And I put 30% on this because the optimal load setting, which is the sideways cut, I have this do a preset that makes the optimal load 30% of the tool diameter, that ratio. Okay, hit OK, and I'm going to regenerate that code. Okay, back again. Now we got it's got some repositioning moves, maybe up, stay down, but I think it's doing pretty good. I could do a quick time study here with machine time, or you can have it come up automatically in your presets, but that's 3 minutes is, I think, okay. We have an 8,000 RPM machine and we can't really spin the tool any faster than that. And the red is the entry one, so we had to, it's actually trying to dive into the part. That's good. Let's do a quick simulate. Simulate. I'm going to change this to my home position. Let me go back to home position and back to simulate. All right, I'm going to do this by steps. If we press the round ball here, step 1, step 2. Now we have a little more stair stepping. I was able to get down deeper because of the smaller diameter, and the outside is still pretty good roughing. Only it cannot get all the way down to the model. So let me make this transparent. There's your model and not model. It couldn't get down in this area here. So I think we need to go to a slightly smaller end mill to get into this area here. So we're going to go to the next size down, and we're going to do 3D adaptive again, but we're going to do 1/4 inch flat end mill. And we selected that out of our library, milling, flat end mill, and we went down the list. We went 1/2 inch, 3/8, now we're at 1/4 inch. We selected the adaptive 30% again. And in this one, we're going to start to engage some stuff here, because we did it with just doing the whole part, and it tries to remachine everything. And we don't need to remachine everything. We want to engage rest machining for sure from previous operations. And we don't really need to machine the outside because we don't define that. So we've picked this boundary as how far out. We want to stay inside. I could have also picked this boundary. So let me do, instead of none, I'm going to do selection. And I'm actually going to pick this one right here. So I'm going to uncheck those chains, select this is my boundary, and say stay inside of that area. But don't machine everything that's already been machined. And I'm going to use the same selections. But in this one, I didn't want to machine above this, so I picked my top height as being aligned with this area here. If I don't pick that, I do model top, this will still work. And this one is still adaptive. We have smaller load optimally because you got a smaller tool. We're still using, we were playing with the fine step down. That's the intermediate stair steps, and the maximum roughing step down, which is as big as the part, 750 or bigger. And we left the same stock to leave, same smoothing settings, and we still have helical entry engaged in case we need it. Still got 70% stay down and 10 thousandths on lift height and 400 on non-engagement feed. All right, we'll let this regen for a second. Let's see what we get. Okay, so it added more. Let me just turn on the blue lines, and you can actually see, I think I see pretty good, but some wasted motion. So it does not need to cut up here. Maybe I should have made my boundary there. That might have been one way to fix it. And it's trying to spiral in from up here. So I think we can improve on that, but I think I can see it's actually cutting the floor now. And it's doing a little bit of the hump part. So let's see if we can improve that. I'm going to edit, and let's go to boundary selection. I'm going to unclick that. I'm going to click this as my boundary. Hit OK, and we have to let it regenerate again. Okay, remove those cuts up here. I still see the spiral entry move here, but this is definitely improved for sure. It's got a little bit of steps on the side, flat milling on the bottom, and stair steps going up there. How can we change this entry position? Let's go to edit, and I think that has to do with the heights. So it's staying top height, which is the top of the cut, it says right there, is starting from model top. So let's change this to selection. I'm going to select this face right here as the top of where the cutting should begin, and probably could even be lower than that, but this should improve it. Okay, definite improvement here. So this red area is the spiral in part. Definitely would be improved. But let's make sure we have no collision issues. Let's go back to simulate. Center this up a little bit. We go step 1, step 2, and step 3. Now we have better roughing. Let me change this to operation comparison. So you can see them stair steps a lot better now. And this is just roughed out. This looks pretty good. You can see the boundaries of the chamfering up here, but this is a, I think, pretty good operation. We can stop roughing and go to finishing. So let's go to finish the outside contours with flat end mills, do the chamfering, do the whole work, and we'll probably finish with a strategy to do the 3D machining on the inside. Okay, thanks. We'll talk to you later.